Law of syllogism. So, before attempting the law of syllogism, make sure you do know your truth tables very well, you're very comfortable, and you understand that for your conditionals, if you have a conditional statement where the hypothesis is true and the conclusion is false, then we know that the overall conditional will be false. Okay, that's the only case that is going to be false. So we're going to use that to fill out this truth table. So that way we can understand what the law of syllogism is telling us. So what I'm going to do is I'm going to pretty much fill out the P, Q, and R as either true or false. Okay, so I'm going to think of all the possibilities so I can have them all be true. And you can, if you notice here too in our table, that we're going to basically use P, Q, and R to form conditional statements. Right, we're going to have a conditional statement where P is the hypothesis, Q is the conclusion. I'm going to create another conditional where Q is the hypothesis, R is the conclusion, and then I'm going to form a third conditional where P is the hypothesis and R is the conclusion. So I'm going to fill this out, as true or false, and there's only 8 possibilities, so they could all be true, and I can have true, false, true. I can have true, true, false, and I can also have true, false, false. So these are all the possibilities when P is true. Right? There's nothing else I could come up with, and then I could also change P to false. So I can have false, false, and false. I can have false, true, and false, 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 and true. And lastly, I can have false, true, and true. So these are all the different ways that P, Q, and R could be either true or false. Next, I'm going to see, okay, so recall what I put a little side note here, that the only time the conditional is false is when my hypothesis is true and my conclusion is false. So I'm going to use this fact to help fill out these conditional statements. So now, in this column, P is the hypothesis, Q is the conclusion. So I'm only looking at these two columns right now. So if I look at the conditional P and Q for this row, well, true and true, I know that's going to be a true conditional statement. And I have true and false, so I know that in this case, that's going to be a false conditional statement. I have true and true, so I know that's also true. Oh, here I have true and false. So if I made a conditional out of this, it would be false. And I have false with false, that's going to be true. False and true, that is also true. False with false, that is true. And false and true, that will also be true. So again, remember, this column is just letting us know that if you make a conditional out of these two with these truth values, right, with this either true or false, right, what is the overall truth value for this conditional statement? Well, the reason why I got these and only 2 of them were false is because if my hypothesis is true and my conclusion is false, that's the only time that this conditional statement will be false. And I look at here, my hypothesis was true, my conclusion was false, therefore my overall conditional statement is false. And I can see in all the other cases, I don't have a true and a false. Alright, so there was only 2 cases. And next, now I'm going to look at the conditional statement formed when I have Q as my hypothesis and R as my conclusion. So if I'm looking at these 2 columns right now, so Q and R. So if I form a conditional statement with Q and R, right, Q is hypothesis, R is the conclusion. In this case here, I have true with true, so that is also true. I have false with true, so that's true. And again, I'm just looking for when you have true and then false, because that's the only time it's false. And I can see here true and false, that's going to be false. This is false with false, so that overall conditional statement is true. False and false again, so that's overall is true. Here I have true implies false is false, so I have that in this row. So I know this is a false conditional statement. False with true, that is a true conditional statement, and true is a true conditional statement. So now I only have 2 cases where if I make a conditional statement where Q is a hypothesis, R is a conclusion, there's only 2 cases where the conditional statement is false, and that is because if you look in this row here, when my hypothesis Q is true, my conclusion is false in this case. Therefore, my overall conditional statement is false. And then for this row here, or this conditional, it's false because, again, if my hypothesis is true, my conclusion is false, then my overall conditional is false. And in every other case, you don't see a true and a false in any other cases, so that's why everything else came out to be true. And then now, here's what the law of syllogism is letting us know. It's saying that if you have a conditional, such as this one, I'll put it, let me highlight this in green. So if I have a conditional, right, P implies Q, right, where P is a hypothesis and Q is a conclusion, and then I have another conditional, right, if I take the conclusion of this one and make it into the hypothesis in my conditional here, and I make a conditional with R, well, they're saying that in the case that both of these conditionals are true, you're able to observe something. So let's just see what that is. If I have true conditional statement, I can see that that occurs in this case here. They're both true here. They're not both true here. They're not both true in this one. They're not both true. I can see they're both true in this case here. And they're both true in this case here. And they're both true in this case here. So these are only cases when they're true. So let's see what happens in these four cases. So if these two conditions are true, what are we going to be able to tell about this conditional if you form such that the hypothesis of one and the conclusion of this one, if you form a conditional out of those two, what will be our truth value? So let's see what happens there. So let's do that one now. So if I take a conditional statement for P for the hypothesis, R is a conclusion, that means I'm looking at this first column and the third column. So I have here true and true, that becomes a true. And here I have true and true, so that is also true. I have true and false, right? If P is true and R is false, and the overall conditional is false. Here I have true and false, so that overall conditional is false. Here I have false and false, so that overall conditional will be true. Here I have false with false again, that overall conditional is true. And here I have false with true, so that overall conditional is true. And then the last row I have false and true, and that overall conditional statement is true. So the question was, what do we notice? If this conditional is true and this conditional is true, which we saw there's four cases, well, what do we notice about the conditional with P and R? So do we notice anything? Well, look at the answers. Let me use a different color. That one came out probably too dark. So if we do, I'll use the blue one here. So if they're both true, what do you notice? Look at this one here. Right? If I told you I have two conditionals such that I'll take the conclusion out of the first conditional, right? And then I'm going to make a new conditional with a new conclusion. And then I take the hypothesis from the first conditional statement, I take the conclusion from the second conditional statement, and I create a new conditional statement. Well, what do I notice about these new statements? Well, they all happen to be true. So that is what the law of syllogism is letting us know. And if I want to kind of clean this up a little bit, we can put here, so this is like in using notation. If I have a conditional statement that is has a truth value of true, and then I have another conditional statement where I take this conclusion and I make it the hypothesis, and then I come up with a new conclusion. If that also happens to be true, then I can make one conclusion without even looking at the third conditional statement. I can take the hypothesis of the first conditional statement, I can take the conclusion from the second conditional statement, I can make a new conditional statement out of those two, and without even evaluating it, I'll know already that it's going to be true. So that's one of the reasons why, truth tables are very powerful, because you're able to determine something, a new relationship, without even having to really, write it all out. If I give you these two conditions, then without even writing my new conditional statement, I'll be able to determine that it will be true because of what we discussed here in this truth table. So that is the law of syllogism.